Now I want to teach you this idea of how to factor a number and down to its prime or its prime factorizations. So let's say I have a number 100. Well, what I'm going to do is I'm going to develop a little bit of a factor tree, which means I'm just going to start looking at factors that go into 100. For example, I know I can make 100 to be 4 and 25. I'm going to keep this process going until my end result becomes a prime number. 4 is not prime, so I can factor 4 as well. 4 is a composite number. It factors down to 2 and 2. 25, likewise, is also a composite number, meaning that it's not prime, and that factors down to 5 times 5. So what I have now is I have this 100 completely factored down. I can't factor 2 anymore, and I can't factor 5 anymore. So the prime factorization of 100 would equal 2 times 5 times 5. Or you might see it written as 2 squared times 5 squared. Now that's not the only way that I could have derived that. Let's look at another way. Because 4 and 25 weren't the only two factors I could have done. I could have done, how about 10 and 10? 10 factors, or 10 times 10, those are composite numbers. 10 factors down to 2 and a 5, and that 10 factors down to 2 and a 5. 2 and 5 and 5, 2 and 5, 2 and 5, those are all prime numbers now. I can't factor anymore, so this can become 2 times 5 times 2 times 5, or rearranged in 2 times 2 times 5 times 5, and 2 squared, 5 squared. So every number that's a composite number, you're going to be able to go ahead and start to factor it down using a factor tree till you get to every end of that tree is some type of a prime number. I want to do one more example for you, and we'll see if this example will kind of work. So let's imagine that we have 36. It's a composite number, meaning it's not prime. We can factor that down. Well, the first one I'm going to do is, I can't think of anything wrong, but it's an even number, so I know 2 factors, and that's 2 times 18. 2 is now prime, but 18 is not. So that trail continues. So I'm just going to circle around that 2, just to kind of remind me it stops. 18 is composite, which means I can continue. That can become 2 and 9. 2 is prime, so that trail stops. However, the 9 continues. The 9 factors into 3 and 3. And both of those stop. So I can see 36 as its prime factorization of all the things I have circled, where the trail ends everywhere. So I have a 2 times this 2, and I have 2 3's down here at the end. And so that factors down to 2 squared times 3 squared. So sometimes when you're factoring a number using a factor tree, one trail may end before the other trail does. And that's completely fine.